So the favorite thing that I like to watch associated with PBS is watching my kids watch PBS. My kids, it's pretty much the only thing. I have a 9-year-old who grew up on PBS, and I have 2 4-year-old twins who are growing up on PBS. And it's the only channel that I can turn on, let them watch, and feel comfortable that if I have to, I can leave the room. Because I know that they're in good hands. I can trust them to PBS.
Coming up on Austin City Limits.
I was born to play this here guitar, and I got blues running through my veins.
Donate your unwanted vehicle to East Tennessee PBS. For more information, visit easttennesseepbs.org.
Join me along with Walter Isaacson, Michelle Martin, Hari Srinivasan, and Alicia Menendez for Amanpour and Company on PBS.
Now is the time. The East Tennessee PBS Be More Awards are here. East Tennessee PBS and Home Federal Bank invite you to nominate area organizations and individuals that help make East Tennessee a better place to live, work, and play. For more information or to apply, visit easttennesseepbs.org. The East Tennessee PBS Be More Awards.
We are driven by our public service mission to provide opportunities for exploration for everyone. We are East Tennessee PBS.
And 5 times 5 is?
25.
Yeah. Hey folks, welcome, and welcome once again out there to Tea and Learn Mathline this afternoon. Hey, it's a Friday, isn't it? It's a great day. I'm Ernie Robert. I am your host for Tea and Learn Mathline, and this is one of our specialized segments days, all right? I got that right, specialized segments. What do we mean by that? Simply, we are going to focus on a topic, and we are going to go a little bit deep, and maybe even deeper, all right? But anyhow, we have a great topic coming up for you today as soon as I figure it out. But let me tell you one thing. It's not a call-in afternoon, so don't try to pick up the phone, call the number, because you're not going to get us, all right? But you can still send us email. We've got the Mathline at tandlearn.org and also Facebook. And, of course, always keep checking us out on YouTube. This show will probably end up there in all of its glory or lack of glory, whichever way it goes, on YouTube also. But anyway, thanks for tuning in this afternoon. Let's see what specialized segment we're going to deal with today. Some number fun for your parallelogram. Oh, parallelogram. Some of you are saying little play on the words, little rhyme going on there. Some number fun for your parallelogram. All right, let's have some number fun for the parallelogram. You know, before we go through the parallelogram procedure of having number fun, let's go back and review a few properties, all right? First of all, some of the things that go on here, we have one question going on here. First of all, which of the parallelogram family have perpendicular diagonals? You said members. What do you mean, Ernie? What are the members? Well, let's go back over those a little bit. Of course, everything is this huge family of parallelograms. If, then here comes the big if. if you have two pairs of opposite sides parallel, all right? Now, when that happens, when you've got the two pairs of opposite sides parallel, other things start happening. One diagonal will form two congruent triangles from that parallelogram. From there, you'll get opposite sides being congruent. Opposite angles will be congruent. Consecutive angles, supplementary, and the diagonals bisect each other, all right? So that's whether they're a square, whether they're a rectangle, whether they're a rhombus, we have those qualities, all right? Now, some of the others get a little specific, all right? Not everybody has perpendicular diagonals in the parallelogram family. Not all those shapes, all right? Specific ones do. Specific ones do. The rhombus and the square are the ones who have perpendicular diagonals. So somebody say, what about the rectangle? Well, the rectangle does have a special thing about the diagonals. They are congruent. They're congruent. And that means the square also has congruent diagonals. So that's a little fact to remember. But the rectangle, unless it's a square, does not have perpendicular diagonals. All right. So perpendicular, by the way, everybody remember that? Form 90-degree angles, form right angles when they intersect, when they come together. So again, sometimes I go back. How far do I go back when I review on these things? I realize some of you just catch us for the first time. So there you go, a few little definitions. Perpendicular means they get right angles. That's going to be inside that parallelogram. So that means a rhombus or a square. Those are the big ones right there. So as we look and think about them, we're reviewing today, all right? We have covered a lot of ground with the parallelograms, but folks, don't feel like you're going to be left out. Stay tuned with us. You haven't been tuned in with us because you'll learn a few good things today and you'll have good fun. Like I said, we're going to have fun with the parallelograms. So everybody wants to have fun on Friday afternoon, don't you? So let's do it. Let's do it. Let's take a look at our first problem that should be a lot of fun. My goodness, it takes up my whole screen here. All right, but it's a picture. And we've got a rhombus and we have a rectangle. Now you say, Ernie, goodness sakes, where? You don't have anything marked. You're right, I don't. So let's mark it together. Let's mark it together. First of all, a rhombus, remember, has four congruent sides. It's a quadrilateral, four congruent sides. It's a parallelogram. Has to be because those both pairs of opposite sides are congruent. That forces it to be a parallelogram. So lots of good things happening. Lots of good things. First of all, let's just mark them. There's a tick mark here, here, and here. Now we'll give you folks a chance to draw this picture at home. It's not that difficult. Create your rectangle. Right there you go. And then push off a nice little edge here and reflect it down from here. Then we're going to crisscross. My goodness, we got the same. See, look at there. That's the same diagonal. Same diagonal. It also incorporates the sides of the rhombus for the rectangle. So goodness sakes. Now remember about a rectangle? What do we know? Well, we know these diagonals are going to be congruent, right? So once we pick up these with one tick, we're going to pick these up with one tick. Why is that? Remember, diagonals bisect each other in a rectangle or in any parallelogram. But we've already established these two guys were congruent because it's a rhombus up here. So that forces this to happen, which helps out greatly. Because you know what else is going on? I just keep saying it. Do you know what else is going on? I hope everybody's seeing this as you're drawing it. You've got a rectangle. So let's pull in some right angles here. Here. Oh, why not here? Here, because a rectangle is a parallelogram with 1, 2, 3, 4 right angles. All right? So a lot of markings. And all of a sudden, the mystery of this figure, which looked kind of crazy at first, disappears. Now, some of you are at home going like, it still looks kind of crazy to me. But we're going to play it out. We're going to play this thing out. Now, by the way, the 64 degrees is right there. That's the only thing I'm telling you. So you say, well, Ernie, there's no instructions. Well, I kind of want us to draw first, and then we're going to play with it, all right? We're going to find angle measures. We're going to find angle measures, all right? That's what we're going to do based on the fact I gave you 1 degree. Actually, 64 degrees, but in one place. 1 angle degree measure. And take a look at this, and let's think. Let's think. One more hint. You say, oh, there's another hint, Ernie. There's one more hint. What did we just ask you in the review moment just probably 2 minutes ago? What did you ask? What about the diagonals? Where do we have perpendicular diagonals? Well, we don't here. They intersect and they bisect each other in the rectangle, but they are certainly not making right angles here. But where do they make right angles? In a rhombus or a square. Remember, we have, hey, there it is, Mr. Rhombus, all right? And that means right through the middle here, we also have some great 90-degree angles. So that's pretty easy. Everybody can figure out, 90 degrees right there. 90, 90, 90, 90. Now the question is, what else is going on with these in these rhombus situations? Well, let's get one thing at a time. Let's start putting some numbers in. We can certainly feel our way around the rectangle here, all right? So remember what I said, what was really important here? We were able to put these tick marks here, and some of you are going like, well, why? Because now I have little isosceles triangles running rampant right here. Oh, I've got a little isosceles going up here. I got a little isosceles going here. There's so many isosceles triangles here. We're not going to try to count them all, okay? Because y'all go like, whoa, you know. But let's take care of those. Because remember, if you have two sides in a triangle that are congruent, have the same length, that means the angles opposite those sides are also congruent. So I started us off with 64 right here. That means we've got a 64 right down here. Isosceles triangle. Isosceles triangle. Now, don't forget. So what am I not going to forget? Got 180 degrees in a triangle, correct? So we can work our way right into this little guy right here, this one of the many angles of C. Let's go for this one that is kind of to the right of that vertex, all right? Let's look for that one. We got 64 and 64, which gives us 128. So what's the magic number? Calculator time? Well, let's do a little mental math. How about a little mental math? Can we do that? I think we're going to see, what do you think we're going to see, folks? Click, click, click out there. Think about it. 52 degrees? I believe that's where we're going. 52 degrees, because those will give us 180 degrees. While we're at it, let's go ahead and swing back across, because it's vertical angle time. Oh my goodness, we got 52 degrees going there. Now, we'll talk about what's happening here in just a minute. We'll talk about that happening in just a minute. But we're going to, at this point, we're going to keep working along here. Keep working along, because something magical is going to happen. We've got right angles here. That means we're going to have right angles here because of all these parallel lines running through. Haven't even mentioned parallel lines yet, have I? Well, let's do that. How about it? Right here, DE is going to run parallel to BG. Why is that important? Why is that important? Well, why don't we take a little breather here, and let's transfer to this triangle. I had 64 degrees, and look at this. We have alternate interior angles popping up. We have alternate interior angles popping up. Oh my goodness, because we got big transversals that connect these lovely lines, all right? So, guess what? These two angles, follow where I'm going here. I'm going to put them in red this time so we can keep up, because it's getting messy, isn't it? This angle is 64 degrees also. And if this is 64, guess what? We've got another isosceles triangle building over here. That's going to be 64 degrees. So already we've got two beautiful triangles. They happen to be congruent because we've got all sorts of sides matching. Opposite sides of a parallelogram are congruent, and it certainly means opposite sides of a rectangle are congruent. So these little bow tie looking triangles match beautifully, which means their angles are going to match beautifully. All right? Yeah, we're just beginning, aren't we? All right, now, we got right angles, and I know some of you are itching to use them. All right? I am. I know I am. All right, let's see what we got going here. We got 64, and something adds up to 90. You guys can do that in your head? Well, if not, hit those calculators real quick. 90 minus 64, I'm coming up with a nice, pretty 26. All right? And that, folks, will make a nice total of 90 degrees, which means right angles. It's a rectangle. That's how I know. That's how I know. Now, let's keep working around here. That means this is going to be 26. You say, Ernie, how'd you know that? Because, well, because I have, goodness, I have another isosceles triangle. See that? GCE. Again, GCE. Two congruent sides means two congruent angles. Now, I'm ready to get going on this middle business here. All right? Question mark. Since these are running, by the way, these run parallel also. There are so many parallels in this problem. That's what's beautiful about it. All right? Take one piece at a time. By the way, I want to point out something to you. A lot of you looked at that and said, man, that's just all over the place. There's so much going on. Take it one step at a time. Don't try to overwhelm your senses here and try to figure everything out in like that. Take it a piece at a time. These are little problems. And see, once you got 64, you unlock 26. And by the way, once I brought in these parallels here, and remember we've already said there's a right angle here, that means there's a right angle here and here, which makes life nice because we've got 90 and 90 going on down there, all right? Let's figure out what's happening up here. Let's figure out what's going on up here. I believe, you know what? I believe we're going to get 180 degrees in that triangle. Let's bring a 64 right into play. Right there we go. 64 and 64. Question is, do I get 180 degrees? I do on that line. I do along that line. Straight angle's working great. We are coming along wonderfully. Go ahead and put some more vertical angles in there. I don't want to lose C, but that's 64 also. All right. So my goodness, we're doing it. We are getting there. We are getting there. So what's happening right here in this one? Another right angle. Goodness, these right angles are awesome, aren't they? That's why we love rhombus. That's why we love square. That's why I love rectangles. They have right angles involved, some size, shape, or form. Now, let me caution you, rhombus does not have right angles necessarily in the angles of the rhombus, but the diagonals right there in the middle, that's where the right angles are happening, all right? So, and they're also happening there if you put a square down, plus the square has 4 other right angles. So right angles play such an important part. That's what we love. That's what we love building with rectangles and squares, and architecture all over the place uses that. Look around your house, look around your room, look at the floor, look at the ceiling. You've got them, all sorts of things. Now, let's keep working out of this thing, lest I lose anybody else. 64, why not? 26 right up here. Y'all notice how this is all of a sudden just unfolding beautifully. Because again, right angles, 26 and 26. And, how did I say? 90 here and 90 here. Why not? We know C is 64, all right? So now we're kicking along. Let's go one more notch here. Just got a few more left to pick up. How do we decide what's going to happen here? Well, you know what? Opposite angles in a parallelogram are congruent. And that works for a rhombus too. And there's another little trip here. The diagonals of a rhombus, they bisect each other. They're perpendicular. But one more thing, folks. They bisect the angles of the rhombus. So I've got 26 here. Bisect means what? We have the same measure right here, 26. Over here, the same story, 26. And you know what? We've already decided these are 64 and 64. I believe we're going to have 64 and 64 up here at the top. Wow. One angle triggered everything. That's how precise. They have to work together. All these things have to work together. So that is our number fun to begin with parallelograms, and especially, in this case, the rhombus and your rectangle. I'd share that with your friends. Recreate it. Do what you can with it. It's a fun problem, and we work it out slowly and surely together. I bet some of you got it faster. Some of you are going, whew, but wasn't it cool when you started seeing all these numbers reappearing and reappearing? That's the beauty of the parallelogram, the rectangle, and the rhombus, and how they all work together. I like this problem. I really do. I hope you were able to stay with it, and hope you enjoyed working through it also. So that's what we've got going here a little bit. Now we're going to take it a little bit less crazy, all right? We don't have, goodness, I don't even know how many answers you had on that page. And if you wanted to add those 26s and 26 together, you got 52. You got some other angles that you could have found in there, but we found all the little guys, all the individual pieces that you could see. And of course, from there on, you can add things together to name all sorts of other great angles in that picture. Now, let's take a look at our next guy here, next little problem. This one has a rhombus. Let me pull it down just a little bit there. All right, now we can all see. If the perimeter of a rhombus is 40 inches, perimeter, distance around, correct? And one diagonal has a length of 12 inches, find the length of the second diagonal. You're going like, whoa. Well, what did we say about diagonals? Well, first of all, we need to draw them, don't we? So I threw that ruler down there, or a straight edge down. Let's see what we can do here, all right? Pull across. There's one. Almost. There we go. And let's pull another one here. Oh, rhombus. I love rhombus. They're good things. If I could just make the diagonal work where I want it. Slide over just a little bit more. Yeah, right back to the same place. You get the idea, folks. Well, I'd rather it look a little better. Let's try that again. That's one thing. Sometimes your ruler wants to slip. Well, it still wants to slip. Y'all get the idea. All right, let's play this thing out. My goodness. All right, with the, maybe if the dots will make it look a little better. Not really. All right, remember what we said about the diagonals. They do bisect each other, so right here and here, those are congruent, as are these, but not the same amount of ticks because they're going to be different lengths, all right? What I do know is the perimeter of this rhombus is 40 inches, 40 inches. So let's put a 10, a 10, a 10, and a 10. There we go. Why? You know what else? Rhombus. All four sides are congruent. So see, being a rhombus really gives us a lot of ammunition to work with if we know the properties, if we know our properties. Now, what else did we mention first of the show? In the last problem, over and over, we have right angles right here in the middle. So there we go. We have nice little right triangles. Ding, 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 ding. That's what I want you to notice. That's very powerful. In fact, these triangles have all the same 3 lengths for a side. No matter what these other 2 numbers happen to be, they have the same lengths, all right? So 1 tick here, 2 tick here, 3 tick here. So triple S, we could also use with the right angles here, side angle side. We get a hypotenuse leg even, because you got your hypotenuse, you got a leg from the bisected diagonal, and then the right angle. There are all sorts of ways we can make this thing work. And if you want to really get picky, you can apply every single possible postulate and theorem for congruent triangles to that to make sure those are all congruent. They match. They're beautiful. They work well. With the properties of your rhombus, there are a lot of things going on there. Now, back to one diagonal. It says it has a length of 12. You know what's going to happen here? We're going to split. We're going to split that 12 into 6 and 6. There we go. And I'm seeing a right triangle situation. And you say, well, Ernie, are we looking for angles here? No, we're looking for what? Length of the diagonal. So there's got to be a way to get that length to work or to find it because we have right triangles. Oh, yes. Our friend and colleague Pythagoras. Pythagoras, yes. So let's go back and work that thing through. Pythagoras says what? A squared plus b squared equals to c squared. We have a right triangle. That's the Pythagorean theorem. If you have a right triangle, the sum of the squares of the legs, which are your a's and b's, added together will give you square of the hypotenuse. Well, let's play it out. Let's see what happens. So the storyline here, I said we'd start with this little a squared plus a b squared, and we'll say it equals to c squared. Got it going out there, everybody? Let's put a 6 in there for a. Let's leave b open because we don't know what b is. We're going to find it. Over here, we've got the hypotenuse 10. We will square. By the way, these are squarings, right? Everybody's going to be squaring. Don't just write 6, but square it, or else we will have some strange looking answers, okay? Now, we got 36 plus your b squared equaling to 100. And we subtract that 36. Let's go for it. And I've got b squared equaling to 64. That's nice. You know why it's nice? Because it's a perfect square. So b equals 8. 8 units of whatever. Now, let's go back one moment here. Question asked, find the what? Length of the second diagonal. Second diagonal. My friends, that's half that diagonal. So that's an 8. And that means, yep, we got an 8 up there also. Because diagonals bisect each other. Hey, they're congruent triangles, all 4 of these. Once you got one of them, you got the other. The whole diagonal will equal 16. Whatever units you've got, feet, inches, meters, does it say here? We have inches, so let's call it inches then. That's what these will be, yeah. So, and by the way, it works whether you have feet, inches, meters, whatever. You're going to have basically an easy a squared plus b squared equals c squared. And by the way, we've got to get it back to the square root. By the way, that's what we did. For some of you are going like, where'd that magic happen? Right, there we go. We square root 64. 8 times 8 will get you 64. That's where we get 8. We have to double it to get back to the whole length of that diagonal. Great problem, great problem. I hope you followed me, and I hope it worked for you. And let's do one more rhombus, a special rhombus. We call it the square, all right? So here we go. We have a diagonal length. Let's see if I can do a better job drawing a diagonal on this thing than I did the last one here. We're going to try again, folks. Let's see where we're going with this. Let's see how my pen does. Hey, that's much better. That looks pretty good. It looks pretty good. Now, it is a square. It is a square. So we have all right angles. We also have, what makes a square so cool, we have also all these congruent sides. So it's a rhombus with right angles, or it could be a rectangle with 4 congruent sides. That's what a square is all about. This time we're telling you the length of the diagonal is 10. That's all we're telling you. Oh my goodness, what are we going to do? Well, notice, whatever these are, they're the same. Whatever you find for one, you got 4 of them. So let's play it back here. Let's see what we're going to do. We've got to work this one through pretty quick, don't we? So, how about it? I'm going to put an A and an A here. And you say, well, Ernie, why don't you put A and B? Because I could. But I'd still be looking for what? The same value. So A is equal to A. So, I mean, it's isosceles triangle, so these two have to be congruent. And some of you are saying, well, could you put a 10 over there? No. The hypotenuse is always the longest, always the longest. So these two guys, yes, they are congruent, but they're going to be shorter. So that's how I know that's A and not C, all right? Besides that, looking at the hypotenuse for 10, life is good. Now, yes, we could have played it over here the same way. Some of you like looking at your right triangle going in that manner. So let's do it. Let's go Pythagorean here. We've got A squared plus A squared equaling to 10 squared. I count. Did you ever think we're going to do 1 plus 1 again in our life? Yes, we are, right here. 2A squared equals, what's 10 squared? Not 20. Don't put 20. No, you're in trouble if you do that. 10 squared is 100. Let's divide by 2. Divide by 2. And life is good. Life is good when we do that because we have A squared equaling to 50. Now, some of you say, do we go to our trusty calculator? You could do that. You're going to get about almost 7.1 or 7.071, I think, something like that. But let's do radical form, all right? Let's just use radical form, and it's a pretty thing. Let's see what would happen with that. It means we're going to square root 50. And I want you to think a little bit. That's because the square root of A squared is A. Let's break this thing down into a perfect square times a number. Well, 25 is a great perfect square. 1 doesn't help you, by the way. 25 is the number we want. Think quarters. That's like 2 quarters there, all right? So 25 times 2. I have a perfect square right there. Pull it out. Its root. Pull the root out. It's 5. Put a root of 2 back on it. There's your length. Okay, that's your length is 5 roots of 2. Now, one more quick thing, and we can do this very quickly. We've got to find the perimeter. We're going to take 4 times. So the perimeter is going to equal 4 times 5 roots of 2. And you know what's going to happen? You're not going to multiply 4 times 2. You're just going to multiply times that 5. Final answer, I'll put it over here. Perimeter equals 20 roots of 2. And that would be whatever units we were using there. It didn't say, did it? Just said it was 10. Hey, thanks for tuning in. We'll see you again next time live, and don't miss us then.